I think we're going to go ahead and get started again. All right, everybody have a nice break. Get up, stretch, get some refreshment. Feel better? All right. So we're going to get back into the swing of things. We're going to talk about the next of our vulnerability categories, sensitive data exposure. Fun trivia fact, in the original version of these slides that all had Firefly backgrounds, this was Nathan Fillion sitting on a rock in the desert. Some of you may know the scene. We decided to omit that for reasons of copyright and taste. So sensitive data exposure is not necessarily about sitting out in the desert on a rock. It is about failure to properly protect your credit cards, tax IDs, authentication credentials, the things you really, really don't want somebody else to have about you. And that sensitive data deserves extra protection, such as encryption at rest or in transit, and special precautions when you're exchanging it with a web browser. So things that might be problematic. Maybe you don't encrypt data that's worth encrypting. Maybe you're holding credit card numbers in plain text. No one in here would ever do that, right? Unsafe generation of your keys or storage of your keys. Maybe you don't rotate the keys. You might use a weak algorithm like SHA-1 instead of doing SHA-256, or ROT13 when you want to blowfish instead. Or like LinkedIn, you may use really weak or unsalted hashes, and that's also no good. Another flavor of this kind of problem is insufficient transport layer protection. So you might not authenticate, encrypt, or protect the confidentiality and integrity of sensitive traffic over your network. So you might use weak algorithms for that. You might not be using the top-of-the-line SSL up to current standards. Maybe your certificate is expired or not valid. Or you might have your certificate being used incorrectly. So some bad things that can happen to you include compromise of all your data that should have been encrypted, LinkedIn, and it can be highly sensitive, right? So we're talking about stuff like your login credentials, credit card information, personal data, health records, all these kinds of things that you really, really, really don't want someone else to have about you. They can expose individual users' data. You can have accounts being stolen. What if you were able to compromise an admin account this way? That could be bad news. And a bad SSL setup can facilitate phishing and man-in-the-middle attacks as well. Because if you're trained to not, maybe you've got a self-signed certificate, and you train your users to just, oh yeah, that's fine. Then an imposter who also has a bad certificate can look like or impersonate you. So you're really not paranoid if they really are out to get you. There are a lot of examples of sites being hacked to get shell access to those machines. And once somebody gets in there, into your network, you can sniff all kinds of terrible stuff. So you want to make sure that you're protecting that data while it's moving around inside your environment. So an attacker could monitor traffic of your users. That could be in a public place like Starbucks or a conference Wi-Fi, OSU free Wi-Fi. It could be on the back end as well. So inside your environment, could be inside your network. It could, between your front-end web server and your database, between your front-end web servers and like a payment environment. And
a lot of these things, like we were talking about before, are really chained exploits where someone got onto your machine because they did a remote code execution, and now they're looking at the data going over the network because you forgot to encrypt it because you thought that internally you were secure. But as soon as you start chaining these things together, they start falling like dominoes.
Yeah. So to prevent this kind of attack or these kinds of issues, you really need to encrypt your sensitive data at rest. So encrypt your passwords, hash them securely, encrypt your payment data, user information that you don't want to get out, health data, that kind of stuff. Make sure that your offsite backups are encrypted as well, and manage the keys separately. Don't back up your keys to the same place that you're backing up your encrypted data. You want to use strong standard algorithms and strong keys, because if you're like, oh, I'm an encryption genius and I made my own encryption code because I'm such an encryption genius, no, you didn't, and no, you're not, and it's going to be destroyed, and you're going to have a really bad day eventually. Like we talked about, you want to hash passwords with a strong standard algorithm and use an appropriate salt. You want to talk about that a little bit, Dave?
This is what people typically don't do.
Yeah.
So you would want to use a salt that is basically randomized across each thing that you're encrypting, and you store that with the encrypted value. And the salt isn't necessarily a secret. It's there to help prevent someone from looking at all the data and trying to figure out patterns. So use the salt and use some secrets to hash the password using a secure algorithm that not only can you not reverse it, but you can't do a lot of the attacks that look at patterns and looks for certain bit formations to break it.
Yeah, you also want to protect passwords and keys from unauthorized access. So you want to make sure that it's not easy to get your encryption keys. They shouldn't be just lying around where an attacker who gets on your box can see them easily. If we really want to require SSL for all pages. They're going to be accessing sensitive data. Redirect all non-SSL requests immediately to SSL. Don't even try to process them. So like your user profile page, your login pages, that kind of stuff. Making sure you set the secure flag on a sensitive cookie. So there's a when you're doing a set cookie header, there's actually a flag you can set that will say that this cookie is only allowed to be transmitted over HTTPS. Again, only strong SSL algorithms for doing SSL. And ensure that your certificate is valid, that it's not expired, not revoked, and that it matches your domain. So, you might use a self-signed certificate in a test environment that trains people to sort of just blindly say, like, yes, 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 that's fine. Just go away, little pop-up. I want to go ahead and browse this. But that can open you up to man in the middle once you're trained to just blindly accept those certs.
And even a lot of code just checks the fact that a cert was given on an SSL page and not necessarily the cert was valid. So you want to make sure that if you're using Python to go and grab a site, that you check the cert. Usually there's a Boolean flag of some sort to actually validate, but you want to make sure the cert is valid for the site you're pulling down. So you're not pulling down someone else's data masquerading as that site.
Yep. And inside your network, use SSL and encryption for that transport as well. So just because it's on the inside of your network doesn't mean a bad person, maybe a disgruntled employee, maybe some attacker who's managed to get in. Maybe it's some ops guy who is in the cage all the time, or is the disgruntled hosting person who's in your network.
And if you're on the
make sure that,
cloud provider too, this is really important because you're not always secure between nodes.
Right, and
it's not obvious that you're not.
There have been problems with some of the cloud folks like a year or two ago, right? That you could just see all the internal traffic between people's.
Well, I believe my Rackspace nodes can see all the other Rackspace nodes on the network.
Yeah, I think AWS had similar issues. Yeah, so not to single Rackspace out.
So I mean, if you go and you actually look at who can see your network and who could do certain things with your network, you'd be surprised at where the access comes from. And that's not just like attacking to get access to it. It's just that the way things are structured, sometimes people just have access. So you want to make sure that the right people are allowed to see the data and the wrong people are not allowed to see the data.
I apologize if I'm sort of jumping the gun.
Yeah.
But I just wanted to say, because it is related to this, with the current state of, if you structure things correctly, or incorrectly, somebody could do script injection on the client side. And even going through an SSL connection, if they would suddenly have access to anything that is not cross-domain restricted.
Mm-hmm.
So I actually encrypt all the data that we send twice, and especially if you're using local storage, because a third party could access all your data on the client side that way too.
Well, that's another good example of combining those attacks, where you're combining injection and other attacks to exploit data that should be secure. So doing that extra double encryption is your way to kind of prevent that. So
data at rest might not just be data in your database. It could be data that's at rest in a flash cookie or something on the client side. So some Django-specific advice. Use Django contrib auth.
This is already done for you if you use Django, so you don't want to go and reinvent the wheel.
Yeah. So that'll help you make sure that your salts are good and your hashing is good. Require SSL in Apache or Nginx, whatever you're fronting Django with. For the places that need it, absolutely require that in there. And there are various middleware things, different middleware solutions you can apply to your Django sites that will force things to load in SSL or that will generate, like for URL generation, you can flag them for being generated with HTTPS links so you can save yourself the redirect even.
And all this really requires that your SSL is set up correctly, got the cert the right way, and it's all installed the right way.
Yep. All right. So that is number 6. So number 7 is missing function level access control. We'll get some little hands-on again here. So when you've got missing function level access control, this means your application isn't protecting its internal functions properly, either due to misconfiguration or developers forgetting to put code checks around particular pieces of functionality. And you could be attacked, say, with an authorized user changes a URL or a parameter to be some privileged function, or an anonymous user accessing private functions that aren't protected. Doctoring cookies could be a vector for privilege escalation. And just because you don't publish a URL, you don't link to a URL, doesn't mean that people won't eventually find it just by messing around, banging on things either with a script or trying to be clever. So this is another place where you can lead to compromised user accounts, compromised administrative accounts, and the big bugaboo again of unauthorized use of the privileged like admin functionality. So let's do an exercise. We're going to manipulate the URL and access some privileged functionality. And let's see where that is. Let me get my... Yeah, so we didn't do sensitive data exposure because proxies don't work against your local host. Let's do this instead. I'm trying to remember how long this one is. I think this is pretty straightforward, right? So this is like a minute or two? Yeah. Yeah, at most. This is a very happy little page. All right, hands up as you guys finish this one. All right, you're there. Okay, cool. Oh no, it's the super secret admin interface. I hope no bad guys get in here. So it's not as common to use the query string to grant privilege escalation, but there's definitely a lot of cases where cookies can be used. Do we have another one on this, or is that... No, yeah, that's that. Okay, so hey, that's number 7. That's the exercise. That's pretty exciting. So to prevent this, you really have to be conscientious and consider every page that you're going to have on your site. Should that be public or private? Is that something that everybody should get to? Should it be something that only certain people can get to? If authentication is required to get to that resource, you need to make sure that the proper checks are in place. And if you need additional authorization, say you need to be an admin user beyond just being logged in, make sure that those checks are in place as well. By default, you want to deny all to those protected resources and explicitly grant access to specific users or specific roles of user.
And to kind of go a little bit deeper on some of these, basically I have a friend that works for a client that runs APIs and other stuff behind the scenes for sites. And one of the things they noticed when they bought a new company is that the company was assuming that the front end was validating who was allowed to have access to an API and was just letting any API request through. So if you looked at their JavaScript, unminified it and restructured it, you would look at it and you would say, oh, they're accessing this API using this key that's right there, and here's the values that they're passing in. So you as an attacker can then very easily just use that for your own use. Instead of having some kind of authentication on that level, they were just expecting your browser to really do it. And that's a really, really bad thing to do.
Yeah. So specifically for Django, what do we do?
So, I mean, a lot of this is very related to other things we've already covered. Like permissions architecture helps you understand who's allowed to access what stuff. You put people in groups, and you allow groups to see certain functions. gives you decorators to protect different views. It gives you other tools to make sure that people are allowed to access parts of the site. So you definitely want to make sure that you're using those things and you understand how they work. And then I don't know why this is on here again, but effectively anything.
It's another useful thing about this, right?
Well, I mean, like anything that you're doing on the admin or anything that you think is an admin, you'll see a lot of sites admin equals 1 or T, and I don't know if that's an open source thing that people are using, but like right there you can look at it and say, you know what, maybe someone else knows how to exploit this thing. So you want to make sure all those functions that you could use for privilege escalation are somehow locked down, and you're thoughtfully going through and making sure they're locked down.
Yep. All right. Any questions about that one? Yeah.
So I'm kind of curious, is there a way to make Django deny all for views by default? So you have to decorate something as being permitted for specific people instead of deny it?
Okay, so the question was, is there a way for Django to deny all by default? You have to specifically decorate it with access to let somebody in? Okay, I understood that correctly. That's a good question.
I don't know. I've never had anyone ask that before. I'm not quite sure if you could do that. I'm sure there's a way. I don't know if it's an obvious way.
Yeah, I think pretty much like anything you expose, you're thinking that you want to be giving people access to. But
that's a really good question. I want to follow up on that.
Yeah. Anybody else? Okay. All right, so this one will be a little more involved again. I think this is the meat of the back end here, this is the second half here. Cross-site request forgery, or CSRF, which sounds a lot more fun. So this is where an attacker is tricking you into submitting a forged HTTP request. So it looks like it is coming from your website, but is not. And the attack succeeds if the user is authorized or authenticated to be able to perform whatever the action is. So things that can be vectors for CSRF are like image tags. Cross-site scripting is basically an example, or can be an example of a CSRF attack as well. Fake buttons that entice you to click on them because, I want to see like awesome cat pictures or something. Phishing forms, so you get the form that purports to be your bank and you got to log in to make sure you update your security settings or whatever, but it might not actually be your bank, and various other techniques. So, like we talked about, there was the Facebook example, right, where you could post an image tag to somebody's wall that as soon as they saw it would log you out of Facebook. So now you've just denial of service attacked somebody by posting a comment on their wall.
I'm pretty sure you can still do that to Gmail right now. If you had an image link to a logout URL, you can put that on your site, and if they visit your site, they're logged out of Gmail.
Yeah, I think we actually would have a link to some information about that coming up. So some possible consequences of this, right? So a victim could change any data that they're allowed to change. So you could cause them to go and do some action that changes data. You could cause the victim to perform any function that they're authorized to use, like log out or post a comment or friend someone or wasn't there a worm that ran around
on Facebook?
On Facebook, friending people?
Basically, it would go from person to person and allow them to post something on a wall that would get to everybody else. It would automatically friend somebody, and it would just like propagate across the entire network. Yeah.
So the impact really of this varies based on the role that the victim has and what they're allowed to do. So we've talked about some possibilities. So here's a link to that particular Facebook problem. Gmail has this issue. The title of this is great. Does Google understand CSRF? So you can basically send someone a link that will log them out of Gmail. That's not the most harmful thing, but is annoying, and they should really fix that.
Wonder what else you can do if you tried.
So what we're going to do is we're going to craft an image link, an image, that's going to trigger some site functionality. This is also something that could be done using an iframe as long as that GET request will cause something to happen. So this could be someplace, could even be buried in an ad, deep down in some ad network 7 layers down. Basically, we're going to make a nasty image link. And how much time do you want to give for this, Dave?
This is a little bit longer. I'd probably say 8 or 9.
All right, I will start it at 10, and we'll see how everybody's doing. Sound good? Awesome. All right, so let's get back to this. And actually, we just had somebody make a really good point that we overlooked earlier about the sensitive data exposure. Logs. Logs are a very, very dangerous thing too, right? You want to make sure that you don't have your sensitive data logged in a log unencrypted as well.
Or sent to Sentry in a traceback, or
Right.
there's probably a bunch of ways that your data gets out there that you don't even think about.
Yeah. So it behooves you to wrap that in something that doesn't get serialized to plain text very easily. All right, so let's talk about CSRF image attacks. So this is, again, about, in this case, we're manipulating the query string here. So let's take a look at the solution. I'm going to walk people through it, and I'll bump up the text a little bit.
And this is extremely similar to one of the exercises we already did. It's basically using the same kind of technique to generate some image with the right URL so that when the URL is viewed, it actually triggers an action on the server side. So in this case, we set up the fact that we wanted this email, and we're going to create the element. We're going to, right here, when we're actually constructing this, you can see that we're actually building all that data into the URL as if the form was posted. So if you went to the browser, you posted the form, and you looked at the form data, we're just basically stealing that URL encoded value and putting it in the query string as though it was the form. And when we use Eurolib to quote this, we can actually pass that in the query string now. So the act of doing this is effectively posting the form, even though we're using a get. And so that kind of highlights one of the security ways to prevent this is that validated is a post, because it's a lot harder to do this as a post.
Yeah. I don't think this... Oh, here we go.
So now in the background, we've added the image to the browser, and the browser then triggered an image request that looked like a form post to the server. So imagine if this was your bank, and you were saying, hey, I want to transfer $10,000 over to this account, right now. And then they just pass that URL out to other people.
Yeah, so put that, and you just sprinkle that image or that hidden image or some link that puts that, sprinkle that out among, out in the world. Put it in people's Facebook walls. Put it in high trafficked places, and you'll just start having funds funneling in if people are authorized.
It's interesting too. If you did this and the link was to Bank of America, and say they had this problem, and you said, "Give me $10,000." If you weren't logged into Bank of America, this would generate a bad image, and since it's display none, you wouldn't even see it. But if you were logged into Bank of America at the time you viewed the image, and they had the flaw, all of a sudden the money would be.
I think on the gift card, when we looked at that, the amount was expected as a text.
It's a text field, but it had to be an integer value that you passed into it.
Okay.
Yeah. All right. So yeah, we were just talking about the bank scenario. Okay, so we can also do CSRF attacks through form posts. So we're going to create an innocuous-looking form that's going to post to a vulnerable location. Maybe we want to see cute kitten pictures, because those are awesome. So we're actually going to go and monkey with some stuff in the page in this exercise. So if you're using the VM, you're going to log on with bad guy as the username and bad guy as the password, and we're going to go edit the template for that. And we can walk you through, if you're one of those folks using the VM, we can show you where to go to find that template. Otherwise, I think the instructions are in the exercise as well. So if you're running in the virtual env, you should just be able to go edit the template right away. Yeah. I'll throw 10 minutes on. All right, cool. So in the interest of keeping everybody moving along here, we'll talk about the solution for this. Do we actually have a...
I think we just talked through it last time.
Did we talk through this last time? Okay. So basically what we did, or what you want to do... Oh, you know what I think I did? I actually did this live on the thing last time, didn't I?
I don't remember.
No, anyway.
Do it live?
No, I don't want to do it live. I never want to do it live.
There it is. I didn't terminate my input there.
Let me see if I actually can do it live. I might have it still in my buffer from a million years ago. CSRF. So basically, we're going into, which is the third-party one. Yeah, you know what? I think I probably rolled this back. That's a bummer. Yeah, sorry. So basically, we pasted that same form in, but made the inputs hidden and changed the button to be something like, show me cute cat pictures.
And
So,
effectively pressing the button, or if it was an image or whatever, would trigger the form, and the user wouldn't know it was happening. It would just post the data.
Yeah, my daughter is obsessed with cat pictures, so like anytime there's a new Twitter post from Emergency Kitten, it's like a holiday for her. It's like national emergency. Like, oh my God, there's a new Daddy, is there a new Emergency Kitten? Anyway, so things to do to prevent this. Don't do things on a get, right?
You want to be safe and make sure that, gets are really easy to mimic. So you want to be safe and make sure that if you're doing real manipulation of data, it's a post or a put, so that you could put the proper controls in place.
Yep. General CSRF protection is include a unique token in some hidden field, often used in concert with a cookie. So that way you can validate that the token was good. You actually had a request that originated from your site, and you want to obviously validate that token. And you want to avoid ever putting that token in the query string where it's going to be visible, something that would be easily stolen, replayed.
Right here, the whole token thing is basically the fact that we're basically tricking the user into using something on our site or some other site to post a form to the site we care about. And so the token allows you to make sure that the form itself originated on the site that it's supposed to post to. So you can't just post from anywhere. It has to...
Right. Like if you're a bank, you want to make sure, if you're Bank of America, you want to make sure that when you receive a post, that was a post from a form from Bank of America that you initiated, that you originated.
And from that user.
Yeah. So some Django-specific advice. Don't change the built-in settings. Django comes out of the box with CSRF protection on. Don't turn it off. We explicitly turned it off to be able to do this. In general, Django has a very good security stance out of the box, and we had to deliberately abuse it to do all the things we're doing today. Do use the CSRF middleware and template tag in your forms.
Yeah, so Django has a layer in their middleware that allows them to automatically look at the form for you, even before it gets to your app code, and just kick it out if it looks bad. So using the middleware basically protects it, and using the template tag basically enables it in the HTML, puts the token
Yeah,
in.
and it'll actually error if you're doing a post and you don't have the CSRF token at all.
Yeah.
So you'll find out real quick that you need to put it in your forms. And be very, very careful about deactivating it, like with the CSRF exempt decorator. There are some valid use cases for that, but you really have to be conscientious about
You
it.
want to think long and hard if you're going to use exempt.
Yeah, so you want to especially be careful about things that are, third party or APIs. If you're using TastyPie or doing OAuth stuff, you want to be careful about wiring all that good stuff up.
It's a little bit harder because you can't use a lot of the built-in tokens and stuff out of the box. You kind of have to use the same concepts. But some of the libraries now are starting to include those things with them.
All right. So we're going to try to race to the finish here. I would love to get you guys to another session if you want to be able to do that too. So number 9 is using known vulnerable components. Well, no one would do that, right? That's dumb. So libraries, frameworks, and other modules will almost always run on your app with full privileges of whoever they're installed by. And it's really hard to stay up to date on them. I don't know all the components that we use, and I don't even know their versions, right? Do you know all the things we use?
If I look at the requirements, I will.
Yeah, well, maybe, yeah. So components with known problems can be identified and exploited by automated tools, and that is bad news. So an attacker can identify a weak component through scanning or even manual analysis, customize an exploit, and the deeper the component is, the more difficult that kind of attack is. But if it's like up at the front layer, and you find out that that's a vulnerable thing, like you can get in there and do some bad stuff.
I mean, Apache is a component.
Yeah,
Right? It's not just our app code; it's everything in that stack.
Right. So that could be your load balancer all the way down, right?
Yep.
So possible consequences of really the full range of weaknesses are available. The impact could be minimal, or you could lose the host completely, compromise your data, go out of business, be very sad. That's not good. So don't use components you don't write. Well, that's not really realistic, right? Because we just said, hey, you're not a crypto genius, don't write your own crypto. So really what you need to do is you need to make sure that you keep all the components that you use up to date. Watch out for security updates. Keep an eye on them. So you want to identify everything that you're using, the version that you're using, and monitor the security of those things. So when there are updates, update. Specifically to Django, when Jacob says there's a security release, you should go and update. You should go and do the security release. Oh, go upgrade. It's important. Any questions? Upgrade's good for you. All right. Number 10, and our last little bit of exercise is unvalidated redirects and forwards. So this is where an attacker is tricking a user into visiting some URL that redirects or forwards the request onto another location. And you're prone to fall for this as a user because you want to click on it. It looks like it's to a legitimate site. It looks believable. Why, sure, I'll click on that link. So things we might be able to do with this, install malware. We might have some kind of phishing exploit through this. We might be able to bypass access controls to get into functionality that you shouldn't have. So there are a couple of quick exercises we're going to do. One is about external redirection. So basically, we have some URL that just redirects to other URLs, and we're going to redirect it to the external location of your choice. And this should be like super quickie. Yeah, so our code base has a page that redirects you to somewhere, so you can copy the link and do stuff to it.
Yeah, if you click on it, it's going to go automatically, so you want to copy the link and look at what it's trying to do.
I'm only going to leave this going for like a minute. Yeah, so a reason you might use something like this, because you just asked, do people still use this? There are certain web browsers that will, if you're on a HTTPS page, you want to submit a form, and then when the form is done, you want to redirect, and say you want to redirect like out of secure land back to like a non-secure page. Because, I don't know, you have an imbalance of, you don't want to have your whole thing SSL only. And there's some browsers that when confronted with a redirect from a secure to a non-secure location will throw a nice error in your face that scares users and makes you think you've done something bad. So a way to work around that is to have a page that takes a URL in and then does like a meta refresh or JavaScript-based redirect. All right, everybody pretty much has this figured out. This is basically as simple as going to example.com, except that I'm not connected to the internet because the Wi-Fi was hitting me earlier. That's basically what it is. Our next one is about forwards. Forwards are where you might be redirecting from, say, one view to another view in Django speak, like under the hood. So you got a request for resource X, and maybe because of something on that payload, or you got told some URL or some action that you're going to take, it's going to send you to some other place. Yeah. So in this case, we're going to bypass access controls with that. And we're going to exploit that to access our super secret admin area. Oh, look at that. So this is telling us we're going to forward to the happy URL, or the happy control view. But we can't. So I wonder what other stuff there is. No, there's no foo. Is there an admin? Hey, it's a super secret admin interface. And now your day is bad again. You're getting paged. Life is bad. And that is the last of the exercises. So to prevent this, don't use redirects and forwards if you can at all help it. If you do have to do redirects or forwards, don't involve any user-supplied data when you're building that redirect location. And if you do have to do this, make sure that the value that comes from the user is valid and is authorized for that user. You want to make sure the user is okay to do that and to go to that place. You don't want to send any non-admin user into admin land. Specifically to Django, they did a security release about 6 months ago, 7 months ago now. I think like November maybe last year, December. They added a Django utils HTTP is safe URL function. And what that does is it is intended to check a redirect URL to make sure that it's on the same site that you're on. So you're not getting redirected off the site. You might want to consider wrapping is safe URL if you also have to redirect to off-domain URLs. Like I need to redirect to PayPal or something. And then there are certain things you might want to whitelist as well. The is safe URL is used internally by the Django contrib auth stuff so that you don't get redirected out to somebody's nefarious evil phishing form that looks like your login or any of your forgot password or that kind of stuff. So, 10 vulnerabilities in 3 hours. That's pretty exciting. So, who out here has vulnerable apps? Okay, we did this sort of earlier. People have vulnerable apps. It's fun. Hooray. Okay, so some parting thoughts to leave you guys with, and you can get up, stretch legs, and go find other talks to do this afternoon. So think like a bad guy. A lot of times, we're in meetings, we're talking with business owners and people about like, hey, you really don't want to do this way, or hey, did you think about X? And we get told, well, nobody does, why do you think like that? Who thinks about this stuff? Well, bad guys do, and it behooves you to think like them so that you can prevent them from doing all of these things. Another really important thing is don't stop at the top 10. These are just the most common vulnerabilities. There are a whole lot more things out there that can get you, and you should be aware of those too. The 10 is a great place to start, but don't let it be the place where you stop. You also need to be aware that it's a world of constant change. Like a couple of years ago, some of those examples worked, and then people fixed their browsers. There's also constantly new vulnerabilities and new exploits being found. So you have to stay on top of things. You have to pay attention. You have to be ready to change and adapt what you're doing, change your practices, and improve. But above all, you need to think positive. All this security stuff can be really, really scary at first because, oh my God, hackers are going to get me. They're going to take all my money. They're going to ruin my business. They're going to destroy my user base. I'm going to be on CNN looking like a jerk, right? It's going to be no good. But no, think positive because, by being aware of these issues, by putting together robust processes and being conscientious and diligent about what you're doing, you can protect your users, protect your data, protect your business, and then everybody wins. And, what was the thing this morning that was VC funded that we were talking about? The stuff for dogs, your image site for dogs. Bitcoin for dogs, that's right. Then your Bitcoin for dogs stays glorious and makes you $1 zillion. So a few links that are possibly useful for you. Go check out OWASP. Go check out the Top 10 project on OWASP.org. The Django project docs have an entire section on security. Definitely worth reading that stuff. They do a really great job of paying attention to security issues. Jacob just got a job being a security guru for Heroku, so he's definitely got this front and center on his mind. And then the GitHub repo, Pirnat/Let's Be Bad Guys. This is going to have links to slides. This is going to have links to the handouts, to a PDF that's got the OWASP Top 10 in it. All the code and stuff that you've been working with today is out there. And if you want to get a hold of us, you can hit us up on our websites. Mine is mike.pirnat.com, and I'm mpirnat on Twitter. Dave is... Yeah, so please, hit us up on Twitter or email or something if you've got questions, you want to talk about other stuff or interesting ideas. positive feedback, shout it to the world on Twitters and Facebooks. Constructive criticism, please come talk to us or hit us up on Twitter, and we can try to make it even better for the next go-around. Thank you, everybody, for coming. I know it was a long session to be in this cramped environment, and I really appreciate everybody who stuck it out, and hopefully you guys all learned stuff and are going to go out and make the world a more secure place. All right, thank you.